In the summer of 1944, the Allied advance across Normandy ground to a halt, not because of what the Germans had built, but because of what the French had cultivated for 1,000 years. The solution would not come from a laboratory or a design bureau, but from a cavalry sergeant who understood that sometimes the answer to an immovable obstacle is not to go over it, but to cut straight through. The hedgerows of Normandy had been growing since the medieval period, raised earthen banks topped with centuries of interwoven roots, bramble and hardwood that formed living walls 12 feet high and 6 feet thick. Farmers had used them to partition the bocage countryside into irregular parcels that protected livestock and marked property lines. To a tank commander in June 1944, they were something else entirely. Natural fortifications that turned every field into a kill zone and every lane into a death trap. When a Sherman tried to climb one of these ancient barriers, the tank would rear up like a stricken animal, exposing its thin belly armor to any German gunner with patience and a clear line of sight. The engine would strain, the tracks would churn against roots that had been hardening since the 100 Years' War, and for long seconds the crew would be helpless, silhouetted against the sky. Sometimes the tank would make it over. Often it would not. Either way, the attack would stall, the infantry would go to ground, and another bocage field would remain in German hands. The problem revealed itself within hours of the breakout from the beachhead. First Army had trained for many things: amphibious assaults, street fighting, river crossings, meeting engagements on open terrain. No one had trained them to fight through a landscape that had fossilized into a natural defensive system over the course of centuries. The pre-invasion reconnaissance photographs, taken from high altitude, had shown the hedgerows as thin lines between fields. They had not conveyed the density, the height, or the sheer vegetative mass that would have to be overcome. Intelligence officers had noted them in briefings, filed them under agricultural features, and moved on to more pressing concerns like beach obstacles and coastal fortifications. Now, 3 weeks past D-Day, with the bocage fighting turning into a grinding attrition that recalled the worst stalemates of the Great War, the hedgerows dominated every tactical discussion from rifle squad to army group. Engineers tried demolitions first, packing Composition C against the base of the embankments and blowing gaps wide enough for a tank to push through. It worked, after a fashion, but it announced your intentions to every German within a half-mile, consumed explosives faster than the logistics train could supply them, and often created rubble piles that were harder to cross than the original hedgerow. Bulldozers could smash through, but they were scarce, slow, unarmored, and needed to be brought forward on transporters. Some units tried using tanks as battering rams, accepting the exposure and hoping speed would carry them through before the enemy could react. The casualty reports from these attempts made for grim reading. A few crews experimented with angling their approach to reduce the climb, but the irregular spacing and varied thickness of the hedgerows made it impossible to develop a reliable technique. The bocage was not a problem that could be solved by courage or by firepower. It required a different kind of thinking. Curtis G. Cullen came from a background that did not suggest tactical innovation. Born in 1915 in New York, he had grown up during the Depression, learning machinery the way other men learned languages, by necessity and immersion. Before the war, he had worked in automotive repair, the kind of job where you made do with what you had because ordering the proper part meant the customer's car sat idle for a week. He enlisted in 1942, was assigned to the 102nd Cavalry Reconnaissance Squadron, mechanized, and crossed the Channel as a staff sergeant in a maintenance section. His war, as he understood it, would be fought with wrenches and welding torches, keeping the vehicles running so other men could do the fighting. He was 30 years old. Too old for romantic notions about glory, too experienced with machinery to think that the tools issued by the Army represented the limit of what was possible. The 102nd Cavalry had come ashore on Utah Beach in early June, and almost immediately found itself mired in the bocage fighting. Reconnaissance elements that were supposed to range ahead and develop enemy positions instead found themselves channeled into narrow lanes where a single POC-40 anti-tank gun could halt an entire column. The light tanks they relied on for mobility were even more vulnerable than the Shermans, their thin armor no match for German guns at close range. Cullen watched the vehicles return from patrol, studied the damage patterns, listened to the crews describe their encounters. He began to understand that the hedgerows were not just obstacles but structural elements of the German defense, and that any solution would have to address not just the physical barrier, but the tactical geometry it created. The idea came to him sometime in late June, though later he would not be able to pinpoint the exact moment. He had been looking at the Czech hedgehogs that littered the beaches, heavy steel rail obstacles that the Germans had in place to rip the bottoms out of landing craft. Now that the beaches were secure, the hedgehogs were being cleared and stacked in dumps, raw material waiting for some useful purpose. Cullen saw them and thought about leverage, about angle of attack, about the difference between trying to climb over a barrier and cutting through it at the roots. The bocage embankments were earth and stone held together by root systems. If you could get underneath that root mat and lever it apart, the whole structure would lose its integrity. The soil would crumble, the vegetation would give way, and a tank could drive through the gap without exposing its belly to enemy fire. He sketched it out on a scrap of paper first, the kind of rough diagram a mechanic makes when explaining a repair. 2 steel prongs, heavy enough to resist bending, welded to the front of a tank at a downward angle, not vertical like a plow, but canted forward so they would bite into the base of the hedgerow rather than trying to push the entire mass backward. The prongs would need to be spaced wide enough to distribute the force, but close enough to concentrate the cutting action. As the tank advanced, the prongs would act like giant chisels, shearing through roots and separating the earth from its vegetative binding. The key was maintaining forward momentum and keeping the tank's frontal armor perpendicular to any incoming fire. Instead of climbing and exposing the belly, the tank would stay level and punch through. Cut, don't climb. Cullen brought the idea to his commanding officer, who had the particular virtue of being willing to listen to a staff sergeant's tactical suggestion. The 102nd Cavalry had been in the bocage long enough to know that conventional methods were not working, and the casualties were mounting with every attempt to advance. If a mechanic thought he could solve the problem with some scrap steel and a welding rig, it was worth an afternoon to find out. Cullen was given permission to build a prototype, access to a damaged Sherman that had been pulled back for repairs, and the implicit understanding that if it didn't work, he would be expected to return to his regular duties without complaint. He worked with a small team, other mechanics who understood the basic engineering even if they couldn't articulate the physics. They cut sections from 3 Czech hedgehogs, heavy rail that had been designed to withstand the impact of landing craft moving at speed through surf. The steel was harder than anything they would normally weld onto a tank, which meant it would hold its edge and shape under stress. They measured twice, cut once, and welded the prongs onto the front glacis plate of the Sherman at a carefully calculated angle. Too steep and they would skip over the roots. Too shallow and they wouldn't bite deep enough to shear the root mat. Cullen had done enough fabrication work to know that angles mattered, that small differences in geometry could produce wildly different outcomes. He adjusted the cant by eye and experience, trusting his sense of how forces would transfer through the structure when it met resistance. The finished assembly looked crude, almost primitive, like something a farmer might weld together to clear stumps from a back 40. 2 steel tusks jutting forward from the hull, braced and gusseted to transfer impact loads into the tank's frame rather than peeling the welds loose on first contact. There was no elegance to it, no consideration for aesthetics or parade ground appearance. It was a tool built for a specific job by someone who understood that the measure of good engineering was whether it worked, not whether it looked like it came from a factory. The crew nicknamed it the Rhino, after the animal, though whether they meant it as a compliment or a joke would depend on what happened next. The first test took place in a field behind the American lines, far enough back that if something went catastrophically wrong, they wouldn't compromise a tactical position. A hedgerow had been selected that was typical of the region, 12 feet high, earthen bank reinforced by centuries of root growth, topped with a tangle of brush and small trees. An audience gathered, officers and enlisted men who had heard that someone in the 102nd had built a contraption that was supposed to solve the bocage problem. There was skepticism, the kind that soldiers develop after enough official solutions turn out to be worse than the problem. But there was also hope, because everyone who had fought in the hedgerows knew that what they were doing was not sustainable. The Sherman moved forward at walking speed, engine rumbling. The prongs aimed at the base of the hedgerow. Cullen was not in the tank. He stood off to the side with the rest of the spectators, watching to see whether his calculations would hold. The prongs made contact with the embankment, and for a moment there was resistance. The tank's tracks digging for purchase as the driver fed power to the transmission. Then something gave way with a sound like tearing canvas amplified to geological scale. The root mat separated from the earth. The prongs drove deeper, and the entire face of the hedgerow began to collapse inward. The tank did not climb. It did not rear up and expose its belly. It stayed level, armor facing forward, and pushed through the disintegrating barrier as though it were made of wet cardboard. 6 seconds after initial contact, the Sherman emerged on the far side of the hedgerow, trailing clumps of earth and vegetation from its tusks. The gap behind it wide enough for infantry to follow on foot. The silence that followed was the silence of men revising their understanding of what was possible. Then someone began to clap, and the sound spread through the group until it became something close to celebration. Cullen accepted the congratulations with the same quiet competence he brought to everything else, already thinking about modifications and improvements. The prototype had worked, but he had seen places where the welds had stressed, angles where the cutting action could be more efficient. This was a first draft, not a final solution. Still, it was more than they had before, proof that the bocage could be beaten by physics and fabrication rather than blood and high explosive. Word of the successful test moved up the chain of command with unusual speed. By the standards of military bureaucracy, Cullen's hedgerow cutter went from field modification to approved equipment in record time, driven by the simple fact that First Army was taking casualties in the bocage at a rate that could not be sustained if they were going to maintain any hope of breaking out before autumn. General Omar Bradley, commanding First Army, saw a demonstration personally and immediately grasped the tactical implications. A Sherman with a Rhino cutter could approach a hedgerow from any direction, without requiring engineer support or exposing itself to catastrophic vulnerability. It could create its own paths of advance, forcing the Germans to defend the entire perimeter of every field rather than concentrating on predictable avenues of approach. Most importantly, it would restore momentum to an offensive that had been grinding forward at a pace measured in yards per day. Bradley's enthusiasm was matched by that of General Dwight Eisenhower, who understood that the bocage stalemate was not just a tactical problem but a strategic one. The plan called for Allied forces to be racing across France by August, threatening the German frontier and forcing a climactic battle that would determine the war's outcome in the West. Instead, they were bogged down in Norman farmland, losing men and machines to a landscape feature that appeared on no enemy order of battle. If Cullen's device could change that calculus, then Eisenhower wanted it on every tank in the theater as quickly as it could be manufactured or improvised. The order went out: priority fabrication of hedgerow cutters for the entire armored force. This presented immediate challenges because there were not enough Czech hedgehogs to equip the hundreds of Shermans that First Army had in theater. Engineers began surveying other sources of heavy steel. Damaged German fortifications yielded I-beams and rail. Knocked-out panzers were stripped of structural members that could be cut and repurposed. In some cases, sections of the Atlantic Wall itself were dismantled to provide steel for the cutters. There was a certain poetic justice in using Rommel's beach defenses to break through the Norman interior, though no one wasted time on symbolism when there was work to be done. Field welding teams were established behind the front lines, working around the clock to fabricate and install the cutters. The design was refined through iteration. Prong spacing was standardized, weld patterns were reinforced, gussets were added to prevent flexing under load. Some tanks received 4 prongs instead of 2, creating a wider cutting surface. Others had their prongs angled more aggressively for particularly dense hedgerows. The beauty of Cullen's original design was its simplicity. It could be adapted and modified by any competent welder without requiring specialized tools or technical manuals. By the middle of July, more than half of First Army's Shermans had been fitted with some version of the Rhino cutter. By the end of the month, it was standard equipment. The first combat use of a Rhino-equipped Sherman under fire took place on a morning that started like any other Bocage engagement. Infantry pinned down in a narrow lane, German machine gun positions enfilading the approaches, and a conventional Sherman stuck trying to climb a hedgerow while a PaK-40 waited for the perfect shot. The Rhino tank, commanded by a lieutenant whose name was not recorded in the after-action report, approached from a different angle, came at the hedgerow head-on, and punched through in less than 10 seconds. The German gunners, who had been tracking the conventional Sherman and waiting for it to expose its belly, suddenly had an armored vehicle in their flank at close range. The Rhino's 75mm gun traversed, fired twice, and the PaK-40 position ceased to exist. The infantry followed through the gap, the lane was cleared, and the advance continued. The entire engagement, which might have taken hours using conventional tactics and cost a dozen casualties, was over in less than 5 minutes. The psychological impact of the Rhino was as significant as its tactical utility. Tank crews who had been approaching every hedgerow with dread now drove with something resembling confidence. They were no longer dependent on engineers, no longer forced to choose between suicidal climbs and time-consuming detours. The Bocage had not become easy, but it had become manageable. Infantry learned to recognize the distinctive profile of a Rhino-equipped tank and to position themselves to exploit the gaps it created. The tempo of operations began to accelerate as units that had been measuring progress in fields per day started thinking in terms of miles per day. German defenders, meanwhile, found themselves facing a problem they had not anticipated and could not easily counter. The Bocage defensive system had been predicated on predictable enemy behavior. Tanks would attempt to climb hedgerows at certain points, infantry would advance along certain lanes, and defensive positions could be sighted to exploit these patterns. The Rhino disrupted this calculus completely. A Sherman could now appear anywhere, at any time, bursting through a hedgerow that the Germans had considered impassable terrain. Observation posts reported tanks appearing in unexpected locations. Forward defensive lines were outflanked by armor that cut through the hedgerows rather than following the lanes. German commanders, accustomed to the meticulous planning and firepower superiority of Wehrmacht doctrine, struggled to adapt to an enemy that had suddenly become vastly more mobile within the close terrain. The first German response was to increase the density of anti-tank gun positions, covering approaches that had previously been considered secondary or unlikely. This consumed guns and crews that were already in short supply, stretching the defensive system thinner and creating gaps elsewhere. Some units attempted to reinforce hedgerows with additional obstacles, digging deeper ditches on the far side or emplacing mines in patterns calculated to catch tanks breaking through. These measures had limited effectiveness. A tank that could shear through centuries of root growth was not going to be stopped by a ditch that could be bridged with fascines. And mine patterns that worked against predictable avenues of approach became much less effective when the enemy could create new avenues at will. A few German units tried using the Bocage for ambush tactics, positioning assault guns in concealed positions and waiting for Rhino tanks to break through before engaging at close range. This worked occasionally, but required patience, coordination, and local numerical superiority that the Wehrmacht increasingly lacked as July turned to August and the American buildup continued. The fundamental problem for the Germans was that the Rhino had changed the geometry of the battlefield in a way that favored attackers over defenders. The Bocage had been their ally. Now it was merely terrain. The most telling indicator of German confusion came from intercepted communications, where unit commanders reported encountering tanks with special ramming equipment and requested instructions on how to counter them. The responses when they came were variations on standard anti-tank doctrine: engage at maximum range, target the tracks and running gear, concentrate fire. These were sensible suggestions for fighting Shermans in general, but offered no specific solution to the Rhino problem. The truth was that there was no easy counter. The Germans could destroy individual Rhino tanks with the same weapons they used against any other Sherman, but they could not prevent those tanks from breaching the hedgerows, and that was what mattered tactically. Some German commanders proposed a more radical solution: abandon the Bocage defensive lines entirely and fall back to prepared positions further inland. This recommendation was rejected by higher headquarters on the grounds that it would concede too much territory and allow the Americans to break out into open country where their superiority in armor and air support would become decisive. The alternative was to continue defending the bocage with weapons and tactics that had been optimized for a problem the enemy had already solved. It was a choice between bad options and worse ones, the kind of dilemma that characterized German decision-making in the West throughout the summer of 1944. As Rhino-equipped Shermans became ubiquitous across First Army, commanders began discovering uses for the device that had not been part of the original design intent. In urban fighting, the prongs could be used to tear through rubble barricades and collapsed buildings, creating paths for armor in cities where tanks were normally relegated to supporting roles. During river-crossing operations, rhinos proved useful for cutting through heavy vegetation on riverbanks, providing concealment and defilade for bridging equipment. One enterprising engineer unit used a rhino tank to clear a path through a minefield by pushing the mines aside with the prongs, a technique that worked exactly once before someone pointed out that it was statistically certain to result in a catastrophic detonation and probably violated several safety regulations. The most unexpected secondary use came during the winter fighting in the Ardennes. When the Germans launched their offensive in December 1944, creating the salient that would be known as the Battle of the Bulge, they achieved tactical surprise in part because bad weather grounded Allied aircraft and heavy snow disrupted ground reconnaissance. American units found themselves fighting in conditions where visibility was measured in yards and roads were blocked by drifts that reached above the hull of a tank. Rhino-equipped Shermans, which had been distributed throughout the forces facing Germany, proved invaluable for breaking through snowdrifts, clearing roadblocks, and punching through hasty German defensive positions that would have stopped conventional tanks. The device that had been designed to solve a Norman hedgerow problem turned out to have applications anywhere a tank needed to force its way through an obstacle without climbing over it. This adaptability created its own set of problems. As the Rhino's utility became apparent, commanders began tasking the equipped tanks with missions that pushed beyond the original design parameters. A device meant for shearing through route mats was being asked to demolish reinforced concrete, push aside burned-out vehicles, and breach obstacles that would have been better handled by specialized engineering equipment. In some cases, this over-aggressive tasking led to mechanical failures. Welds would crack under repeated shock loads that exceeded what they had been designed to handle. Prongs would bend or break when used against materials harder than earth and wood. The tanks themselves would suffer transmission damage from the accumulated stress of forcing their way through obstacles that conventional tactics would have recommended bypassing or reducing with explosives. Maintenance crews found themselves dealing with a new category of wear patterns. The Sherman's drivetrain had been engineered with certain assumptions about how the vehicle would be used, and those assumptions did not include repeated high-load impacts against fixed obstacles. Cullen's design transferred much of the force through the front hull, which was structurally sound, but some of the shock still propagated back through the suspension and final drives. Tanks that had been using their Rhinos aggressively began showing accelerated wear on components that should have lasted months longer. Ordnance depots received requests for replacement transmissions at rates that exceeded the planning factors. It was not a crisis, but it was a reminder that every engineering solution creates new engineering problems. More seriously, there were incidents of friendly fire involving Rhino tanks in low-visibility conditions. The protruding prongs changed the vehicle's silhouette enough that, at distance or in poor light, a Rhino Sherman could be momentarily mistaken for a German tank with an unfamiliar weapon configuration. Most such incidents ended with recognition before anyone fired, but there were cases where nervous sentries or tank destroyers engaged what they thought was an enemy vehicle and discovered only afterward that they had been shooting at their own side. The after-action reports made for uncomfortable reading. Training emphasized vehicle recognition, but training assumed clear sight lines and daylight conditions. In the fog and confusion of actual combat, especially during the winter months, mistakes happened. The fastest tempo of operations created its own friction. First Army's logistics system had been planned around certain assumptions about how quickly units would be able to advance through the bocage. When that advance suddenly accelerated in late July and August, supply lines were stretched thin trying to keep up. Fuel and ammunition dumps that were supposed to support a week of operations were exhausted in 3 days. Medical evacuation routes were extended beyond optimal lengths. The very success of the Rhino contributed to a situation where forward units were occasionally pausing, not because of enemy resistance, but because they had outrun their supply columns. This was a far better problem than being stuck in the bocage, but it was still a problem that required solution. Despite these complications, the strategic impact of the Rhino was undeniable. The breakout from Normandy, Operation Cobra, launched at the end of July with massive air support and concentrated artillery, succeeded in part because German defensive positions in the bocage had already been degraded by weeks of Rhino-equipped tank assaults. When American armor finally broke through the German lines at Avranches, they were racing across open country that they might not have reached until autumn if they had still been fighting the hedgerows on German terms. Patton's Third Army, which became operational in August and began its sweep across France, inherited hundreds of Rhino tanks that had been proven in the bocage and could be adapted to whatever obstacles the retreating Germans placed in their path. By September, when Allied forces were approaching the German frontier and the hedgerows of Normandy were hundreds of miles behind, the Rhino had become such standard equipment that its revolutionary nature was already being forgotten. New crews receiving Shermans from replacement depots assumed the prongs were factory equipment, part of the tank's original design, because they could not imagine the vehicle without them. The fact that the entire American armored force had been retrofitted with a field modification in the space of 6 weeks, solving a tactical problem that threatened to derail the entire campaign, was already fading into the background noise of a war that produced 1,000 technical improvisations every day. Curtis Cullen himself received the Legion of Merit for his innovation, a decoration that recognized achievement but fell well short of the Combat Valor Awards that filled the headlines. He was promoted to Technical Sergeant, continued to serve with the 102nd Cavalry through the end of the war, and returned to civilian life in 1945 with the same quiet competence that had characterized his military service. There was brief press coverage when the story of the Rhino reached American newspapers. Stories that emphasized the ingenuity of the American soldier and the democratic nature of an army where a staff sergeant's idea could be implemented at the highest levels. Then, as with most wartime stories, the coverage faded and people moved on to the next thing. Cullen returned to New York, worked in various mechanical trades, and lived a life that drew no attention to itself. When historians of the Normandy campaign tracked him down decades later, he spoke about the hedgerow cutter with the same matter-of-fact tone that he might have used to describe repairing a carburetor. It had been a problem. He had thought of a solution, and it had worked. That it had changed the course of a campaign and saved thousands of lives was simply what had happened, not something that required ongoing recognition or celebration. He died in 1963. His obituaries noting his wartime service but largely overlooking the specific contribution that had made that service significant. The Rhino itself had a longer half-life. As the war moved into Germany and the bocage became irrelevant, many tanks had their cutters removed to save weight and reduce the vehicle's profile. The steel was often repurposed for other battlefield expedients, continuing the cycle of improvisation that had created the device in the first place. Some tanks kept their Rhinos through the end of the war, the crews viewing them as good luck charms or useful general-purpose tools even when hedgerows were no longer the primary obstacle. A handful of Rhino-equipped Shermans were preserved after the war, pulled from scrapyards or identified among the thousands of vehicles being decommissioned and returned to storage. Today, they sit in museums, the prongs painted and preserved, silent testimony to a problem that was once considered insoluble. Modern military historians debate the Rhino's place in the taxonomy of wartime innovation. Some argue that it belongs in the same category as other famous battlefield improvisations, simple solutions to immediate problems, implemented quickly and forgotten just as quickly once the problem disappeared. Others contend that the Rhino represents something more significant, an example of how tactical problems can be solved by lateral thinking when conventional approaches have reached their limits. The device itself was not sophisticated. Any competent welder could have fabricated something similar. What made it significant was that Cullen had the imagination to see the problem differently, the skill to turn that vision into hardware, and the institutional support to implement it at scale before the opportunity passed. The Germans, in their post-war analyses, devoted surprisingly little attention to the Rhino. It appeared in after-action reports and tactical studies as one of many Allied technical advantages, noted alongside air superiority, artillery coordination, and logistics capability. There was no sense of grievance or surprise. By mid-1944, the Wehrmacht had grown accustomed to fighting an enemy that could field technical solutions faster than German industry could respond. The bocage had been a temporary advantage, the kind that competent opponents would eventually overcome. That they had overcome it through improvisation rather than industrial capacity was interesting, but not particularly significant in the larger context of a war that Germany was losing on every front. What the Rhino demonstrated, more than anything else, was the difference between doctrine and dogma. The Army had taught tank crews how to handle a very wide range of obstacles and tactical situations, but it had not specifically taught them how to fight in the Norman bocage because no one had anticipated that particular challenge. When the challenge appeared, the doctrinal response would have been to adapt existing techniques or to wait for higher headquarters to develop and disseminate a solution through proper channels. Instead, a staff sergeant with a welder's torch short-circuited that process and produced a working solution in the time it would have taken for the problem to be properly analyzed. That this was possible spoke to several factors: the technical competence of American enlisted personnel, the willingness of officers to consider suggestions from below, and a military culture that valued results over procedural correctness. It also revealed something about the nature of innovation in combat. The best solutions to tactical problems are often embarrassingly simple once someone thinks of them, but they require someone to think past the official answers and the established procedures. Kulin was not a tanker or a tactician. He was a mechanic who understood materials and stresses and basic physics. He looked at the hedgerow problem from an engineer's perspective rather than a soldier's perspective, and that change in viewpoint was what mattered. The Army had plenty of soldiers who were brave enough to drive a tank over a hedgerow. What it needed was someone who could figure out how to avoid climbing the hedgerow in the first place. The broader lesson extended beyond tanks and hedgerows. Throughout military history, there are examples of simple innovations that change the geometry of combat: the stirrup, the longbow, the trench periscope, the shaped charge. In most cases, these innovations were not the product of institutional research programs or systematic development efforts. They emerged from the intersection of a specific problem and an individual who looked at that problem from a slightly different angle than everyone else. The challenge for military institutions is to create an environment where such individuals can surface their ideas without being crushed by bureaucracy, where a staff sergeant's sketch on a scrap of paper can reach a general's desk if the idea has merit. The Rhino succeeded because the institutional environment in First Army during the summer of 1944 was conducive to rapid innovation. Bradley and his staff were desperate enough to listen to unconventional suggestions. The logistics system was robust enough to support field modifications at scale, and the tactical situation was urgent enough that normal approval processes were compressed or bypassed entirely. In a different context, with different commanders or a less acute crisis, Colin's idea might have been filed away for future study, subjected to a lengthy testing and evaluation process, or simply dismissed as impractical. The fact that it was instead implemented within weeks of conception was as much a reflection of organizational culture as of technical merit. This raises questions about whether such innovation can be institutionalized, whether an army can systematically create the conditions that produce Kulin-style solutions without ossifying into the kind of bureaucratic structure that would have rejected the Rhino as an unauthorized modification. The history of military innovation suggests that the answer is mixed at best. Organizations that become too enamored of improvisation lose the discipline and standardization that make large-scale operations possible. Organizations that become too focused on doctrine and procedure lose the flexibility to adapt when doctrine proves inadequate. The optimal state is somewhere in between, and maintaining that balance requires constant attention from commanders who understand that both discipline and initiative have their place. The Rhino's legacy, then, is not just the specific device, but the example it set. In the decades after World War II, as the Army studied the lessons of the European campaign and codified them into new doctrine, the hedgerow cutter appeared in training materials and case studies as an illustration of the kind of thinking that should be encouraged. Officer candidates learned about Coulin's innovation in the same context they learned about other examples of tactical adaptation. The message was not that every soldier should be inventing new devices, but that every soldier should be empowered to question assumptions and to propose solutions when existing methods were not working. Whether that message was internalized is debatable. Subsequent conflicts produced their own examples of field improvisation, some successful and some less so, but they also revealed the persistent tension between centralized control and local initiative that characterizes any large organization. The Army that fought in Vietnam experimented with countless modifications to its equipment, some inspired and some desperate, but it took years for many of those lessons to be formally adopted. The Army that fought in Iraq and Afghanistan faced improvised explosive devices and asymmetric tactics that required new thinking, and here too there were examples of soldiers at the tactical level devising solutions that eventually became official programs. The pattern repeats. Crisis produces innovation. Innovation produces success. Success produces institutionalization. Institutionalization produces the rigidity that the next crisis will need to overcome. Coulin's Rhino avoided this cycle, in a sense, because the problem it solved disappeared so completely that there was nothing to institutionalize. The bocage fighting lasted 6 weeks. The Rhino was deployed and proven, and then the battlefield moved on to terrain where hedgerows were irrelevant. There was no opportunity for the solution to calcify into doctrine because the need for it evaporated. The cutters were removed, the steel was repurposed, and the innovation returned to being what it had started as, a clever field modification that had solved an immediate problem. In this sense, the Rhino represents a kind of ideal for military innovation, a solution that appeared when needed, served its purpose, and then quietly retired without becoming the sort of permanent fixture that would be defended long past its usefulness. The physical artifacts that remain are few. Museum collections preserve perhaps a dozen Rhino-equipped Shermans, the majority of them in American institutions, though a few can be found in European collections. The cutters themselves are often the focus of special exhibitions, displayed alongside photographs and testimonials that attempt to convey the significance of what looks, to modern eyes, like a crude welding job. Visitors who know nothing of the bocage fighting often walk past these exhibits without fully grasping what they represent. To anyone who was not there, who did not experience the particular frustration of watching a tank rear up against a hedgerow while German guns waited for the kill shot, the Rhino is just an odd attachment on an old tank, a curiosity from a war that ended 80 years ago. For historians and military professionals, the Rhino remains a touchstone, a reminder that the most important innovations are often not the ones that appear in defense white papers or acquisition programs, but the ones that emerge from the tactical level when someone decides that there has to be a better way. Coulin's contribution was not that he invented something entirely new. The concept of a tank-mounted cutter for obstacles had precedence in earlier armored warfare experiments. His contribution was that he built something that worked, using available materials at the exact moment when it was needed most. The simplicity of the design was a feature, not a bug, because it meant the device could be replicated quickly without specialized manufacturing. The modesty of the inventor was similarly appropriate. This was not a man seeking glory or recognition, but someone solving a problem because solving problems was what he did. The story of the Rhino resonates because it embodies certain American myths about ingenuity and pragmatism. The idea that democracy produces better soldiers because those soldiers are educated and empowered to think for themselves rather than merely following orders. There is truth to this, though it can be overstated. The Wehrmacht had its own examples of tactical innovation, and German engineering during the war produced some of the most sophisticated weapon systems of the era. What the Rhino illustrates is not that American soldiers were uniquely creative, but that American military institutions in 1944 were capable of recognizing good ideas regardless of their source and implementing them rapidly enough to matter. That capability was neither automatic nor universal, but when it functioned properly, it provided a significant advantage. 80 years on, the lessons of the rhino cutter remain relevant to anyone thinking about how organizations adapt to unexpected challenges. The hedgerow problem was not something that could have been anticipated in planning or solved by applying more resources to the existing approach. It required someone to reconceptualize the problem entirely, to see that the objective was not to get over the hedgerow, but to go through it, and to understand that the tools to make that possible were literally lying on the beaches waiting to be repurposed. That kind of thinking cannot be taught in a conventional sense, but it can be encouraged or discouraged by institutional culture. An organization that crushes initiative in favor of conformity will not produce Kulins. An organization that values results over process just might. The final irony is that the very completeness of the rhino's success has made it easy to forget. The bocage ceased to be a problem so quickly after the device was deployed that subsequent accounts of the Normandy campaign often gloss over the weeks when it seemed like an insoluble obstacle. Modern readers encounter descriptions of the breakout from Normandy and assume that the breakthrough was inevitable, a matter of applying sufficient force and accepting sufficient casualties until the German line cracked. They miss the fact that for crucial weeks in June and July, there was genuine uncertainty about whether First Army would be able to break out at all, whether the entire invasion might bog down in the hedgerows while German reinforcements arrived and the strategic window closed. Cullen's innovation did not single-handedly prevent that outcome, but it was one of the critical factors that allowed the advance to continue when continuation seemed most in doubt. That the story is not better known speaks to how quickly wartime innovations fade from memory once they are no longer needed. The engineers who designed the landing craft, the pilots who flew air support, the artillery crews who provided fire missions, all of these contributions are documented and remembered because they were part of the sustained structure of the campaign. The mechanic who built a device that solved a problem so effectively that people forgot there had been a problem is remembered, when he is remembered at all, as a footnote. There is no malice in this forgetting, no conspiracy to diminish Cullen's achievement. It is simply the nature of history that the solutions to problems become invisible once the problems themselves have disappeared. In the end, the Rhino hedgerow cutter was exactly what it appeared to be. 2 pieces of steel welded to the front of a tank, angled correctly and braced sufficiently to shear through obstacles that had been stopping entire armies. It was not revolutionary technology or innovative science. It was applied physics and practical engineering, executed competently at a moment when competent execution was the difference between success and failure. That such simple solutions are possible, that they can emerge from unexpected places when the need is acute and the organizational environment allows them to surface, is perhaps the most important lesson the Rhino has to teach. The problems will always be there. The question is whether we create conditions that allow the Kulins of the world to solve them, or whether we inadvertently suppress the very creativity we claim to value. The hedgerows of Normandy are still there, dividing the fields into their ancient patterns, roots as deep as they ever were. The difference is that no one needs to climb them anymore, because someone figured out how to cut straight through.